Saw me code, same proxies, same target. The job went from 4 hours to just under 9. The only thing I had changed was which machine it ran on. I had moved it off my desk onto a rented box because that felt like the grown-up thing to do, and I picked the box on price, and the box turned out to sit on the other side of the world from the proxies I was paying for. So every request now crossed an ocean before it even reached the proxy. About 140 milliseconds of extra waiting on every request for the life of the job. Who is saying this? I sell mobile proxy lines, SIM cards on Singapore carriers, modems on a shelf in my flat, about $10 a month per line in carrier data, and another $50 in depreciation, which means I watch this from both ends. People buy lines from me and then run the job on a laptop in a bedroom. And when the numbers come back bad, the first suspect is always the lines. Sometimes they are right. Often the lines are fine and the machine is the problem, and nothing in a proxy dashboard will ever tell them that. The part that is true, the proxy decides what the target sees. That is not a simplification, it is just correct. The address, the network that address belongs to, the country it geolocates to, whether it smells like a phone or a data center, all of that comes from the exit. You can run a scraper on a Raspberry Pi under a desk in Singapore, and the site will see a residential connection in Frankfurt, because Frankfurt is where the traffic left from. So the conclusion is an easy one to reach. If the target cannot see my machine does not matter. Reasonable enough as conclusions go, and it survives about a week. Distance gets added to every request. Your traffic does not appear inside the proxy. It travels there first. That leg belongs to you. It is added to every request. It appears nowhere in anything the seller shows you, and it is invisible in the one test everybody runs. You open a speed checker through the proxy. You see 200 milliseconds. You shrug. 200 milliseconds is nothing. You would not feel it loading a page. Now send a million requests, 140 milliseconds of avoidable distance across a million requests is 39 hours. 39 hours in which your process is doing nothing at all except waiting for packets to finish walking. Concurrency hides that, which is precisely the problem. With 20 requests in flight, those 39 hours compressed to about 2, so the extra distance never shows up as a longer run. It shows up as needing 20 in flight where 12 would have done. And how many you have in flight is the one number your target is actually counting. I have said plenty elsewhere about choosing that number, and the short version is that you want it as low as your deadline allows. So the cheap box in the wrong hemisphere did not really cost me hours. It cost me concurrency, and concurrency was the thing I was trying hardest to spend carefully. Measure it before you commit, because this is the only part of the decision you can settle with data instead of opinion. Rent the cheapest instance in each candidate region for an hour, time a few hundred requests through your real proxy at your real target, keep the winner, and destroy the rest. It costs about the price of a coffee. The machine has to stay awake. A job that takes 6 hours needs a machine that is awake for 6 hours. A laptop is not that machine. It sleeps on the lid. It sleeps on idle. It sleeps because the battery reached 20% and something sensible took over on your behalf. I left a run going overnight once and came back to a progress line that said hour 2. The lid had been shut for 7 hours and the process had been suspended that entire time politely, exactly as designed. Worse, a scheduled task on a sleeping machine does not queue up and fire late. The hour simply passes and nothing happens, and your log has no entry to be suspicious about. Home connections do their own version of this. The router takes a firmware update at 4 in the morning. Wi-Fi roams to the other access point. Somebody unplugs the thing to charge a phone. And none of it arrives as a clean stop. Sockets hang. Half your workers sit in a read that will never return, and the job neither finishes nor fails, it just stops moving. Then if there is no checkpoint, you start again from 0, which means a second full pass against a target that has only just finished watching the first one. The resolver is a leak path. The proxy carries your traffic. It does not automatically carry your name lookups. With an HTTP proxy and a connect tunnel, the proxy resolves the hostname for you. With SOCKS 5, you get a choice. and the two spellings are one letter apart. SOX5 resolves locally and hence the proxy an address. SOX5H hence the proxy the name. Get that wrong and every hostname you scrape goes to your own resolver first from your own address in the clear. There are other doors to the same room. A headless browser configured casually, a pre-flight lookup buried in your logging, a monitoring check that pings the host by name from the box rather than through the pool. What leaks is only the name, not the request, but the name is the entire point. A resolver log showing one connection asking for the same 50 host names every night at the same minute is not an ambiguous document. The answers differ too. A resolver in one country hands back a different edge address than a resolver in another. So your request leaves through a German exit and arrives at an Asian edge node. That matters much more the moment your target sits behind a CDN, which is a subject of its own. Check it rather than assume it. Send a request through the pool to something that reports back which resolver it saw and read the answer. If it names your own network, you have found your leak in about a minute. A wrong clock looks like a block. I lost a day and a half to this one. Every HTTPS request failing through every proxy all at once. Certificate errors and certificate errors through a proxy read as interference because your first thought is always that something has sat down in the middle of the connection. The box's clock was 3 days behind. It was a virtual machine restored from a snapshot and nothing had corrected it since. A certificate issued yesterday is not yet valid on a machine that believes it is last Tuesday. So every handshake fails, the library reports it as a connection error, and you go hunting for a block that was never there. Anything using a signed request or a time token fails in the same shape. A few minutes of skew and your signature comes back rejected as though it was simply wrong. The fix is dull. One-time sync service, running, verified, and check that the container actually inherited it. Cheap servers ship without one more often than you would expect. Your own machine is fine for some of it. I want to be clear about this because the internet's answer to every question is to rent something. Development, obviously. Anything you are sitting in front of. A one-off pull of 4,000 pages while you eat lunch. Anything you will run twice and then delete. And your home connection is often genuinely the shortest path to the proxy, because it is near you and the cheap server somewhere else is not. So the laptop earns its place. It earns it for work somebody is watching. Anything on a schedule wants its own box. The test is whether a person is present when the job runs. A scheduled job goes at 3 in the morning. Nobody is present by definition. The lid is then a single point of failure that gets closed every night by a tired human being. Small is fine. One core and a gigabyte of memory will run a request-based scraper at a concurrency your target will object to long before the box does. Headless browsers change that arithmetic, mostly on memory, and they change it further than most people expect before they try it. Put it near the proxy. This is the part I had backwards, and most people I talk to have it backwards too. The instinct is to put the machine close to the site you are scraping. Shorter path to the data. It feels obviously right, but you have no path to the site. You have a path to the proxy has a path to the site, and only the first one is yours to choose. The proxy leg happens on every request no matter where you sit. The leg you control is the one into the proxy, so shorten that one and stop thinking about the other. If your pool is mobile lines in Singapore, rent in Singapore. If it exits in Europe, rent in Europe. The target can be wherever it likes, because the exit already decided what it sees. And if you authenticate by whitelist, moving the box means updating the list before you move rather than after. That is an afternoon I have already written about losing. What a server actually costs. A small box is a few dollars a month. Call it 5. I pay twice that for a single SIM card, and the SIM card is the part that makes any of this work at all. So cost is not why scheduled scrapers live on laptops. Inertia is. It worked the day you wrote it, it kept working, and there was never a morning where it broke loudly enough to make you move it. Where I come down, if a job runs on a schedule and it runs on a machine you also use for other things, you have not chosen where it runs, you have just never moved it. People argue with me about this and the argument is always the same. it has been fine for a year. And it has been fine for a year, right up until the row count quietly halves and you spend 3 days reading proxy logs about a laptop that went to sleep. What I cannot tell you, the near the proxy rule assumes there is a near. A pool spread across 6 countries does not have one. Then you are averaging, and my only answer is to sit in the region most of your traffic exits from and accept the rest, which is not much of an answer. I also cannot give you the point where a bigger machine beats a closer one. I have never run a scrape where the processor was the limit, but I do not do heavy browser work at volume either. So treat that as a whole in my experience and not as a finding. And I still leave real jobs on my laptop. Did it last month. The only thing that has changed is that I notice inside a day now, instead of finding out from a row count 3 weeks later. The latency check I run before picking a region and the short list I work through when I set a scraper box up are at proxyscraping.org. Subscribe for more on proxies for scraping